So last time we did sort of a mini demo showing the basics of Cucumber and Capybara. We'll review what happened in that demo, and today we'll go a little bit beyond. We sort of did the simplest possible thing that would work when we wrote our Capybara steps for checking that students are listed in alphabetical order in our little trivial app. And as usual, when you do the simplest thing that can possibly work, there's a pitfall, because as soon as your app becomes a little bit more complicated, the simplest thing no longer works. So we're going to do a second part of the demo that explores that and looks at what a more realistic use of Cucumber and Capybara would be that avoids that pitfall. So to summarize what we did in the first part of the demo, in terms of some mechanics, we found that there's a directory that goes in your Rails app called features. Every file in there has a name that ends in .feature, and it contains one or more scenarios. Usually they're a collection of scenarios related to a single user story. There's also a subdirectory called step definitions, and every file in there has a name like something steps.rb. They contain 0 or more step definitions, and it doesn't matter which one goes in which file because all of the files are loaded in. So usually you try to sort of separate them out in a way that's meaningful for the app. So if you think about our Rotten Potatoes app that we've developing, you might imagine that there are some steps that are related to workflows about movies, but there's other steps that support scenarios related to reviews, for example. So those might go into different files and step definitions, but that's really just for programmer maintainability and readability. And remember, when you're writing those step definitions, that whether the step def begins with given, or it begins with when, or it begins with then, syntactically, those are all synonyms. You choose the one that makes it most readable. So a step definition that generally is used for setting up preconditions, it's more readable if you call it a given. And then the way that these things work together is the step definitions contain regular expressions. Those regular expressions are matched against the steps in the scenario, and any capture groups, parentheses capture groups in the regexes become the arguments that can be used in the body of the step definition. And lastly, we took a look, today we're going to take a little bit deeper look at the page object in Capybara, which represents the parsed subset of a page. And as we'll see, not only does that object represent the subset of the page, you can sort of pick out smaller subsets of the page by calling methods on this page object. And those smaller subsets of the page have all the same behaviors that the full page does. So think of it as like you're narrowing down the page, and then within a subset of the page, you can look for specific things to be true, or you can fill in a form or something. And we're about to see an example of that. So that's a summary of the mechanics of the demo we did last time. As a reminder of what the demo actually accomplished, we were trying to implement this feature on a really simple app that lists the students. The feature specified that the names of the students should be displayed in alphabetical order by last name, not in the order in which students were created. And the really simple way that we checked on that is we used Capybara to generate a request that would show the list of students, and we sort of flattened out all of the structure of the page. We took out the HTML tags, and we asked the page object, just give me back a big Mongo string that represents all of the text on the page concatenated together. And we sort of used a simple regular expression to make sure that one substring occurred before another substring in that page, and that was enough, right? And initially, we had a scenario that was failing because we had not added an order clause to the call to student.all in the controller. And once we added that in, that made the scenario pass, and it was green, and it was happy. So that's where we left off. And the second part of the demo that I'm going to do now illustrates a pitfall in how we wrote the tests. And there's a more general pitfall here about using a Cucumber or a Capybara construction that is too simple. So let's do the second part of the demo, and I'll show you what I mean. As a reminder, here's our trivially simple app. I have it running in a browser window that's small because there isn't really much to see. It's just listing the names of students. And the last time we did this, let's make the prompt a little bit smaller. Okay, the last time we did this, we're verifying that our Cucumber scenario still works, that when I visit the list of students, Armando Fox appears before Tyler Lamb. That's great. And as a reminder, in order to do that, we had to add this order clause. And we can verify that if we remove the order clause and run the test again, as we expect, the test now doesn't pass anymore because basically the regular expression doesn't match. Okay, so this is where we were last time, right before we made the change that makes the test pass. And by the way, as a reminder, that pattern of start by writing the scenario steps initially are yellow because you don't have code. Then they probably become red because you do have code, but it's not quite working. And finally, you make the changes and it's green, and then you go on to the next step, right? That cycle is sort of the essence of behavior-driven design. So now, suppose that we wanted to add a little footer to the bottom of the page, because maybe Tyler wrote this app. Tyler, our beloved TA. And one way to give credit would be, I have some code snippets here that I've prepared, that we could put a footer that says app by Tyler Lamb. And if I reload the page, sure enough, now on the bottom of the page view, because I've added something to the application layout. Now, here's the thing that I want you to notice. If I now run the Cucumber scenario one more time, it's green. And that's bad, right? Because we remembered that to make the test pass before, we had to add that clause to order the results in the way that the test expects. I just removed that order clause. We watched the test fail. So we know that this is essentially a false positive, right? So what's going on here? Very simply, we did something that's a little bit too simple. All we're saying is that Armando Fox appears before Tyler Lamb. And in fact, in this case, I do. It's just the wrong Tyler Lamb, right? So our original plan of let's just do the simplest thing, flatten all of the page's text and just look at a regular expression doesn't work anymore. All right. It's too simple-minded. And again, this app is really simple. You can imagine that if there were other things on the page and stuff like that, then it would actually be even more difficult. So let me actually turn it over to you and ask what's the next simplest thing we could do in terms of fixing our tests that would solve this problem of a false pass, right? We know this test should fail and it's passing. So something is wrong with our tests. What might be a good general strategy to fix it? If we go back to what is the test really trying to say? It's trying to say that within this table, things appear in a certain order, right? Not only do we not care about the stuff that's outside the table, in this case, the stuff outside the table is actually making the test behave incorrectly, not the way we want. So if we look at the view, here is the index.html.erb that actually displays the list of students. Well, let's see. We have a table, and the table has a body. What could we do here? Strategically, don't think about syntax. Just what do we wish we could do? Described in plain language, what do we want to be able to do here? Suppose we could just, the same idea about flattening, but we're just going to limit it to the text in the table. So somehow we have to tell Capybara in our step definition, when you're doing the flattening, don't flatten the whole page. Just grab the table part and flatten that. Now, one issue with doing that is right now, there isn't really a great way to refer to the table, right? We need sort of a handle by which we can grab the table. What's probably the easiest, quickest way to do that? Let's give it an ID. And by the way, we could give the table an ID. We could give the table body an ID if we want it to be even more paranoid. I mean, who knows? Maybe it's sometime in the column headers, Tyler's name or Armando's name might appear in the column headers. But for now, we're going to keep it simple. We'll give the table an ID. I'll just call it students table and save that. And now if we go to our step definitions file, right, here's the step definition that we have now. We're basically constructing a regular expression, and then we're flattening page.text and trying to match the regular expression. So what we need to be doing now is instead of flattening the text of the whole page, we want to flatten the text of the table. Happily, there's an easy way to do that. So if we instead say page.find, and now I'm going to give it a CSS selector that matches the table. And the simplest thing that we did works just fine. We can say the table whose ID is students table. Strictly speaking, you might even say this is redundant. We could just say hash students table, because as we recall in HTML, only one element on a page can have a given ID. So this is technically legal. But I like this for readability. It makes clear to the person reading the step def that the thing we're looking for is in fact a table. And also it's a little bit safer because remember I said browsers tend to be very forgiving about what they will display. You're not supposed to have multiple elements with the same ID on a page, but if you do, the browser will not complain, but Capybara will complain. So being explicit about things like this, I find helps a lot for the same reason that we used create bang up here, right? In a test, we want to make sure that nothing unexpected is going wrong. So anyway, we're going to grab the table. When we call page.find, you can pass a CSS selector. You can pass an XPath expression, which is much more complicated. But basically, kind of lesson number one here is when you're authoring your pages, giving classes and IDs to things has multiple uses. And one of those uses is make it easy when you're writing tests to find the things that you need that test is going to use. Happily, when we call page.find, the object that's returned from that has all of the same behaviors as a page does. So it's like I said, it's kind of like we're getting back a smaller version of the page. So really, now we can just expect table.text to match the regular expression. And we're basically using the exact same technique, but now we've narrowed the scope of it to this one single element. So if we do that, and then we head back to this text window and run Cucumber again, this is good news, right? And I say that sort of in scare quotes, right? When you write a test and the test fails for the right reason, that's good news. If you're developing code, it's good news because it tells you that your intuition about what's supposed to happen is correct. You wrote a test that exercises code you wish you had. It fails for the reason that you expect, and now you go back and write that code. When you're fixing a bug, a test failing for the right reason is great because it means you've isolated the bug. You've reproducibly determined what the cause of the bug is. So in our case, we're happy. And now, indeed, if we go back to the controller and we add back in that order clause and we run the scenario again, then we're back to passing, right? I can't believe that worked the first time. You guys are the privileged few who got to see it. But what does this mean in real life? What are the implications? The first and most important one probably is beware of how expectations are phrased and checked. If you do the exercises that are in the book or the CHIPS exercises, there's a set of files that is provided as a gem called Cucumber Rails Training Wheels. And there's a file in there called websteps.rb, and it's the place where generic steps are defined like, I should see this, or when I click on this, or when I follow that. Be very careful of steps like I should see, because I should see doesn't scope to an element. There's a way to scope it down, but the more general version of this is be as specific as you can. In particular, be careful with negative expectations when you say, then I should not see. Because you know what? If you load a page and what is actually being loaded is an error message or a page full of garbage, you probably will pass the expectation of I will not see. So there's many ways for a test to be wrong. You want to make sure that when the test fails, it's failing for the right reason, if that makes sense. And one way to do that, which we used in this case, is if you're checking for the presence or absence of something on a page, scope it as tightly as you can to the subset of the page where it actually matters. This and much, much more information is available on the Cucumber website. And as I said, I'm all in favor of asking an LLM to generate some Cucumber step definitions for you just to sort of get used to seeing what they look like, get used to what all the different things are that you can do with a page, how to look for elements, and what kinds of expectations on them, which we're going to talk about much more when we do RSpec next week.